So if you're thinking about it, you're a firm, you're deciding how to price whatever product you're trying to sell. Well, if you want to make more money, let's say you're considering raising the price of the good. You need to know, or you need to at least have some sort of idea how people are going to respond to that. If they're going to buy a lot more of that good, or if they're, let's see, your increased price, they're going to buy a lot less of the good or just a little bit less. If people are pretty much going to buy about the same, then you can raise the price and end up making more money. But if a lot of people are going to be sensitive to that price change, they're not going to want to buy the good at the new, slightly higher price, then you're going to end up losing money. So it's important to know when you're pricing these things. So again, elastic demand, that's when consumers are responsive to a change in price. If there's a price change, that's going to change their quantity demanded even more. So for example, this product, kitten mittens, if there's a 10% decrease in price, in this case, so going from $5 to $4.50 for a 4-pack of kitten mittens, the quantity demanded is going to increase from 100 to 120. So because there's a greater increase in the quantity demanded than a decrease in price, we end up with elastic demand. You think about it, putting mittens on your cat is kind of dumb. It's not really a need for people. So you would expect it to be sensitive to price. You wouldn't? Do you think quiet cats are important?
Yeah. Make a lot of money.
Imagine if you had like 40 alley cats outside your window. They'll keep you up all night.
And then you have to eat, maybe just get some cane or something like that.
Yeah, maybe eat some cat food, get some beer.
And help you get to sleep. I don't think anybody else understands that.
Yeah. Luckily, I'm recording though, so you can watch on YouTube later, and everyone can be confused. On the other hand, we have inelastic demand. So for inelastic demand, consumers aren't very responsive to a change in price. So there's a larger change in the price, you're gonna have a smaller change in the quantity demanded. People are still gonna go out and buy that good, even at the new, different price. So for example, let's say there's this awesome movie called Thunder Gun Express. People are super excited about it, considered very high quality, and I don't know, maybe, let's say it's like the third one in the series. So people have seen the first two, they're really into the character. They want to see where the character goes. So for this, if it's inelastic demand, a 10% increase in price leads to, say, a 5% decrease in quantity demanded. So going from $10 to $11, the quantity demanded is only going to drop from 100 to 95. So the percentage drop is smaller than the percentage increase in price. Again, because it's inelastic demand, consumers aren't really worried about the price. Like the example at the beginning of the chapter with gasoline, people tend to use gasoline no matter what, and we'll talk about why later, or the determinants of the price elasticity of demand. But a larger price change for goods like Thunder Gun Express tickets or for gasoline, people aren't going to change their demand very much. So this brings us to actually calculating price elasticity of demand. So let's suppose you're a gas station, and you don't know your demand curve. So it's like a typical market. You can kind of guess at it, but you're not really sure. These curves aren't drawn out for you. And you're considering cutting the price of gas from $3 to $2.70. Now you don't know. Your demand curve could be this demand curve, which appears to be pretty elastic. There's a pretty large change in the quantity demanded from your price drop. Or it could be less elastic. It could be this demand curve here, D2, where this drop is going to lead to a small increase in the quantity demanded. So if we do a simple, let's look at the first demand curve. So looking at D1. So our original price is $3. The new price we're dropping it to is $2.70. The initial quantity is 1,000. And the new quantity is 1,200. So to calculate price elasticity of demand, now because we're not working with percentages, we need, like you're not given the percent change, we have to find the percent change. So the percent change in price equals P1 minus P2 over P1. So your $3 minus $2.70 over $3. Someone with a calculator want to work that out for me?
One over 10.
1 over 10? So 0.1 over 10. Don't think of that, that's equal to 10%. Now the percent change in the quantity demanded, Q1 minus Q2 over Q1. So it'll be 1,000 minus 1,200 over 1,000. You get that one?
Negative 1 over 5.
Negative 1 over 5, so 0.2 or 20%. So then you have the percent change to get the price elasticity of demand. We have the percent change in the quantity demanded over the percent change in the price. So negative 20% over 10% or 2. Well, I guess negative 2. Take the absolute value of that. Price elasticity demand equals 2. Which makes sense. If we look at the curve, we have a large change in the quantity demanded, and it's a flat slope. So we would expect that to be elastic. It's a little annoying when you're given the actual price change to actual quantity. You have to calculate the percentage yourself, so it has that extra little step in there. So how about you guys try the second demand curve yourself? So for this side of the room, I want you to calculate moving from 1,000 to 1,050. So you guys are my right, well, your left side. Q1 equals 1,000, Q2 equals 1050, P1 equals $3, P2 equals 270. And then for the right side, I want you to do the opposite. So Q1 equals 1050, Q2 equals 1,000, P1 equals 270, and P2 equals $3. Try that doing the same thing we did here. So first finding the change in the percent, finding the percent change in price and percent change in quantity. Then divide. All right, so what do we get? Left side of the room. You guys had it easy. You had the same change in percent change in price. Point one. How did you get point one? Okay, so you got the 10% percent change in price. And what did you get for the percent change in quantity? Negative 0.2. What? What did you do?
Oh, I didn't get any for the other side.
You did what?
I didn't go to that one.
This one?
Not at all.
This one? You used like this answer?
No, I mean, the one.
And what did you get from that?
I got, percentage is, 4.76%.
4.76. All right, so I got 0.5 for that. Anyone else get 0.5? Okay. So we end up with, I wrote it down over there behind me, 0.05 divided by 0.10. Which one of these is negative? Top. So that equals anyone? 5? .5. So we end up with inelastic demand is less than 1. The other side, what did you guys get? 0.4? So what number did you get for the percent change in quantity demanded? 4.76? Oh, okay, yes. And then percent change in price?
11.1%.
Or negative? 11. And your final answer?
42.9%.
You don't turn into a percent at the end.
Okay.
So it's just like, just that decimal point. There's no actual units, no percent or anything for price elasticity demand. So yes, so when you go from one side, when you go moving from point A to C, you end up with 0.5. But when you go the opposite way from point C to point A with a price increase, you end up with 0.42. The reason being, as you drop the price, you have a different percent than when you increase the price. So even though this is the simplest way to do it, unfortunately, it's not going to work. So the change going down is not going to be the same percent change going up. So for the initial curve, demand curve 1, quantity increasing from 1,000 to 1,200 is going to be an increase of 20%. When you go from 1,200 down to 1,000, it's going to be a decrease of 16.7%. So even though this is the simplest formula to use and you'd think it makes intuitive sense, because we're working with percent changes, we can't actually use that. So in order to do that, we have to use what's called the midpoint formula, which looks a little more complicated, but it's not much worse than what we just did. So if you want to do the percent change, use the midpoint formula. You take your first term minus the second term, divide that by the average of the first term and the second term. So again, we now have an additional step. So much easier when we're just given the percentage changes. But when we're not, we use this midpoint formula. So whether we're going from the higher price to lower price or lower price to the higher price, we're going to end up with the same result using this midpoint formula. So our new price elasticity demand, the equation that we're going to use, Q2 minus Q1 divided by the average of Q1 plus Q2, divided by P2 minus P1 divided by the average of the two prices. So the first of these is the percentage change in the quantity, and the second is the percentage change in price. So let's go back to that D1 from the previous example. Let's wipe some of this off first. So Q1 equals 1,000, your Q2, 1,200. P1 equals $3. And P2 equals $2.70. So in order to do this problem, we've got the formula, just plug these in and go. So we'll have 1,200 minus 1,000, Q2 minus Q1, divided by 1,000 plus 1,200, divided by 2. Divided by $3 minus $2.70. Oh, did that backwards. $2.70 minus $3 over $3 plus $2.70 over 2. we start working that out, the average, or the difference here is 200. The average there is 1100. Divide that by, difference is 30 cents. $2.85, that average. This will give us 18.2 divided by negative 10.5, and finally negative 1.7. Absolute value of that, elasticity, 1.7. So going from price 1 to price 2 before, we ended up with a price elasticity of demand of 2. Using the midpoint formula, we see it's actually 1.7. Does this make sense to you guys? Basically just plug and chug. For the exam, I will make sure you guys have the formula for the price elasticity of demand. So you don't have to have that like memorized going into it. As long as you know how to work with it and put these numbers in there, you'll be good. All right, so here's a practice problem. It starts it out for you, but try to work on this one yourself. On the price elasticity demand for demand curve 1, D1. So moving from $2.50 to $2.30, from 2,000 gallons of gas to 2,500 gallons of gas. All right, and I have an answer they want to share?
2.677.
What was that?
2.677.
2.677? That's right. So the first slide, they have you, or they show how to calculate the average quantity and the average price. Right here, they do the math in a slightly different order. So the percent change in quantity demand is 22.2, percent change in price is negative 8.3. So you divide those, you get negative 2.7. And again, just using the eyeball test, it's a good way to check your answer. Slope is pretty shallow, so we have a larger change here than we have here. So you would assume the demand is elastic. So the negative 2.7, or the price elasticity of demand of 2.7 greater than 1, that's going to be elastic. This all looks right. Anyone have any questions about how to do this? This is really the only like math problems you're going to have to do in this class. I want to make sure you guys get this so you'll be good for like the exam and everything. All right, let's take a break here. NFL season starts tomorrow. Is anyone excited?
Yes.
I'm in a fantasy league. It's called like a vampire league, where like one team doesn't draft, and they pick up all the free agents they want. And then anytime they beat like a team that actually drafted, they get to pick one player from their team. So if you win early, like you can build an awesome team. If you lose the first couple games, you're kind of screwed. I want to draft tonight. I haven't really prepared. So who are guys I should target? I kind of assumed the season would be at least pushed back. If it like happened at all, so I haven't really been like paying attention to what's going on.
Then give your analysis. Yeah. And then you fall on it.
What pick do you have?
I think I'm pick 4.
Pick 4. I get Kamara first round.
Kamara?
Make sure you handcuff the Davius Murray though.
He's your guy. NBA, NFL.
I like Robert Woods a lot.
Robert Woods? All right. This is basically gonna be my evening. It's like frantically like cramming at the last second to try to figure out who's changed teams this year, whose new offense looks good, stuff like that.
I'm worried about Brady. I don't know how he's going to do.
That's the ultimate crapshoot. He's got Gronk back. Like they could be huge, or it could crash and burn.
Yeah. Gronk's also getting old. I don't know if he's going to do it.
He's out for a year,
Yeah.
so it might take him a while to get back into game shape,
Yeah, he's got a flush out for that system.
and not the performance enhancing ones.
I think it's good.
Pick the act. He's got enough stuff.
You think so?
Dak Prescott.
They say that every year.
Mess up.
See, I have a friend who's such a hardcore Cowboys fan. All he talks about how his Dak is elite.
Dak is now elite.
So it
Zeke make him look good.
He has so many people. He has so many offensive weapons that they just can't do anything.
do they even use Zeke enough? Do they even use Zeke enough?
They use Dak too much.
We've got Tony Pollard.
No, it would be Zeke enough. Dak just can't make the throws, like the mid-range throws, deep throws.
Okay. This is a good start. Technically being paid right now to do fantasy football.
Only wearing
Hardcore hairstyle.
Okay, so some observations on elasticity. Like I mentioned in the beginning, slope and elasticity are not the same thing. Calculating the slope of a demand curve is not going to give you the price elasticity of demand, but they are related. So you can look at the slope of a demand curve as like I said, like a check to see if your answer makes sense. Because for the exam, like from the textbook itself, and then the questions I'll write on the exam, I'm not going to play with the units so that like a curve, yeah, demand curve, the price elasticity of like 1.7, it's not going to be like super steep. It'll be like more flat than like you would expect. So it'll be like drawn to scale, so you don't have to worry about me trying to trick you that way. So you can use that as a way to like check your answer. Does the slope look like it's elastic or look like it's inelastic? And two demand curves go through the same point. So we have, yeah, like those two demand curves right there. Then we can use slope to say which one's elastic and which one's inelastic. Because they're on the same one, we know they have the same units. So using slope makes sense to say which one is more elastic, which one is less elastic. Although if you don't actually calculate it, you can't say whether one is inelastic and one is elastic. There's a few special cases I want to talk about. The first is perfectly inelastic demand. So for perfectly inelastic demand, the quantity demanded is completely unresponsive to a price change. So the price elasticity of demand equals 0. So no matter how you change the price, that's not going to affect demand. It's going to be completely vertical. There's your demand curve for perfectly inelastic. Good. You guys think of any examples of goods that are like that? There's a couple.
Milk, gas.
Gas is very inelastic, but it's not perfectly inelastic.
Milk or something.
What was that?
Milk.
Milk is going to be
Oh, no.
pretty inelastic, yeah, but not perfectly.
Water. Trying to read that.
Even water, people, most of water is like used for farming, for like agriculture. And the price increases, changes for that. I don't know about people's personal consumption. That's interesting. That could be an example. But you're on the right track thinking it needs.
Funeral homes. Yeah, people have done power regardless. They're gonna get business.
I still think that's perfectly inelastic. There's enough firms competing against each other. They can offer different types of services.
Recession proof.
It is recession proof. People always die, people always make trash. Insulin. If you're diabetic, no matter what the price is, you're going to need that insulin. Illegal addictive drugs. So like crack. You get addicted to crack, they increase the price on you. Doesn't matter what your dealer does, you still need that crack. So you're going to go out of Later on, we'll talk about the market for drugs and talk about literally the supply and demand curves and stuff like that. Those are like the only two examples I can think of. There's not a lot of goods that are like that. But there are some where no matter what the price is, no matter how you change the price, the quantity demanded is going to stay the same. So say insulin is like $4 for a week's worth, or whether it's $10,000 for a week's worth. No matter what, you're still in that same quantity, whatever the quantity you need to get through that week. You can also have a horizontal demand curve. So this is perfectly elastic. So people are, the price elasticity of demand is infinity. So I'll bring infinity. You say they're infinitely responsive to a change in price. So what that means is if there's any price change, you increase the price or decrease the, say if you increase the price at all, people are going to reduce their demand to 0. Like what? So one example of this that we'll talk about later in perfect competition is goods that are exactly the same. So for instance, agricultural goods like wheat. if you're buying wheat from a farm, if the farm increases their prices, you'll just go to someone else. And they won't drop their price because they're not gonna increase their sales. It's not gonna help them out at all. This is also a very special, very rare case. You can think of things that are very elastic, but perfectly elastic is difficult to imagine, especially for like consumer goods that we would buy. The last special case is unit elastic, where the price elasticity of demand is exactly equal to 1. That's neither elastic or inelastic, but again, it's very rare to just happen to hit that exact percentage. Okay, and here's some slides. I'm not going to go through them, but I left them in there so you guys can go through them, like study for an exam. It just shows elastic demand, inelastic demand, unit elastic, perfectly elastic, and perfectly inelastic. So yeah, the visual representation, and it shows the quantity, so it gives you an example. At this point, unit elastic, 11% change in price, 11% change in quantity. All right, so the question from the beginning of the section, do people respond to changes in the price of gasoline? So gasoline demand is inelastic. There's not going to be a lot of change in your demand for gasoline based off a change in the price of gasoline. It's not perfectly inelastic because there will be some changes. So for instance, instead of going out and running errands every day, you'll lump them all together on one day. So you do less driving. Maybe you and your friend decide to carpool to work or to class one day. You'll do little things to try to decrease your gas. But at the end of the day, you still have to get to class or get to work. You still have to go out to the grocery store, go and buy other stuff. So there's still a lot of driving, so a lot of gas purchasing you're going to need to do. So here on the left, we have perfectly inelastic demand. So if people did not respond at all to changing gas prices, this is what you'd see. As the supply curve shifts, quantity demanded does not change with the price increases. Here's what we see in the real world for gasoline. A very inelastic demand curve, but there still is some change. So as supply shifts to the left, you still see some decrease in the quantity demanded and an increase in price. And that's consistent with people doing a little bit less driving, trying to save a little bit of money, reducing their gas consumption just a little bit in response to a price change. As opposed to not changing anything at all, like you would see with a crack user or with an insulin, like diabetic who needs insulin. So we'll get section 6.2 started. So you see how some goods have elastic demand, some goods have inelastic demands, based on whether people are willing, how sensitive they are to a change in price. So are they willing to keep buying these goods if the price increases, or if that's going to cause them to buy a lot less? But the question is why? What's going on? What's making these goods? What's making people treat these goods differently? So there's several characteristics of goods and markets and things like that that help determine what the price elasticity of demand is going to be. Whether consumers are going to keep buying if we see a substantial increase in price. And if you're a firm, if you're trying to decide how to price these goods, this is important for you. Because, like I mentioned earlier, if people aren't very sensitive to price, you can increase the price and make a lot more money. Or if you decrease the price and people are sensitive to price, a lot more people are going to buy the good, and then you'll end up making more money than selling it at the higher price. So if you're trying to maximize your revenue, maximize your profit, it's important to know this. Or at least be able to estimate it so you have an idea whether it's elastic or inelastic. Because again, you typically, as a firm, you don't know your demand curves. So the first, and one of the simplest, is the availability of close substitutes. So if you have a bunch of substitutes available for that particular good, people are going to be more sensitive to price. It'll have a more elastic demand. So in the short run, there are very few substitutes for gasoline. So it's going to have a low price elasticity of demand. In the short term, there's not a lot else you can do, to replace gasoline. Maybe you can take public transit if you're in a big city. If you're in Laredo, that's not a choice for you. Again, in a big city, you can take an Uber. But even Altoona right now, that's not a choice for you. Maybe you could bike if it's like close and you don't have to carry a lot of stuff. Again, there's not a lot of substitutes, so people are going to generally continue buying gas even at the new higher price, at least in the short run. In the long run, maybe they buy a more fuel-efficient car so they don't have to buy as much gas. Maybe they do other things. Maybe they buy like a nice bike. They can take places. They start taking public transit, things like that. Now, for another good like Nike, like sneakers, there's a lot of substitutes for that. You can go to a lot of different brands and get similar sneakers. So their price elasticity demand is going to be a lot higher. They raise the price of Nikes, people go out, they say, well, whatever, now these Adidas are cheaper, they'll buy those. Anyone here think that's a bad example? Anyone think it's hard for Reeboks or Adidas's to compete for what Nike has? Maybe Nike's are cooler, more stylish. You don't want to wear like Reeboks like a dad or New Balance. So sometimes it depends on the actual consumer, what needs are actually being met, for whether these are actually substitutes. But in general, if there's a lot of other options, a lot of similar options you can use for a good, then your price elasticity demand is going to be a lot higher. You'll be a lot more sensitive to price because you can just go and get a very similar good from someone else. With that, we have a couple minutes left. I'm not going to keep you guys late. We'll pick up here on Friday.